Can you read the comments? If so, would you move out of New York City? I would highly, highly consider it. Depending on where he goes, Lewis, if you're listening to this, please choose Florida. Hello there, everybody. For those of you that don't know me, my name is Dan. I'm a board tech here at Rossmann Repair Group, and today I'm going to be fixing a 1990 board number 820-01041. For those of you that want to follow along, let me go ahead and show you guys what this board looks like. It's the 15-inch touch bar. I think it's from 2018, around that year. As you guys can see, there's a ton of liquid damage on this board. The customer said they spilled coffee on the keyboard. You see like widespread splatters of liquid. You can see, might be hard to see. I'll show you guys on the microscope soon. Just corrosion all across this board. The customer's main concern here was getting data recovery. Of course, we'd love to fix the board so they have a working laptop as well. Hello, everybody in the chat that has already tuned in. I'm going to go ahead and switch to the microscope so we can show you some of this corrosion. And I kind of want to run you guys through the first measurements I do on these boards, if especially when people are concerned with data recovery. Either way, I usually check all the Ssd signals first. I'll show you guys along, because as you guys can see, just tons of liquid all across. You can see it splattered, some liquid there, liquid here on these MOSFETs across the board. We'll work our way through. And yeah, so first thing I want to show you guys is what readings I take. I'm going to show you guys here. The first main reading I find... Oh, let me pull up the schematic as well. Be easier to show you guys. First signal I always check on this board. I just know where it is from muscle memory. Of course, if you have Paul Daniels board view software, you can check. It's checking P-bus right here. So I'll go ahead and check that. Switch to the microscope. On these two fuses, so we're just going to check this to ground. And it's not shorted. That's always a great sign when you're looking for data recovery. So the next signals I like to check are the Ssd signals. Make sure none of those are shorted. There's actually two sides you need to check on these boards. The first one you find is right here on the bottom. Right here. You can see the Ssd buck controller right there. Let's pull this up on the schematic as well, just so I can show you guys. This is a problematic area on these boards because it's right next to the vent on the side of the boards. As you guys can see, both wings have two separate SSDs, or two different controllers for the SSDs, and since liquid comes in through the vents on the sides and spreads around by the fan, usually this whole area gets liquid damaged. Doesn't look too bad here. I don't see any real signs of liquid in this area, just some dust and corrosion. So I'm going to go ahead and check 2v5 NAND. You can find it on this capacitor right here. And just measure that to ground. Make sure that's, see, not shorted. That's always a great sign. And we're going to go ahead and check the other side of the board as well. Here you can actually see some corrosion on this cap. Going to make sure that's not shorted to ground. That's always not a good sign. Luckily, it looks like the SSD buck might be fine. Just going to pull this up on the schematic. And we're going to check 2v5 NAND on this side. This is P-bus. P-bus isn't shorted, so that cap should be fine. I'm going to measure it anyways. So let's go ahead and switch back to our microscope. And let's measure this cap first. To ground. I'm going to try to get a better work around Lewis's microscope. And we're going to measure this to ground. Not shorted. It's always a great sign, even though the cap looks terrible. We're going to switch that out later. And let's go ahead and measure 2v5 NAND on this side. There. Also not shorted. So that's a great sign. So the first thing I want to do on this board is go ahead and start switching out some of this corrosion. So I'm going to start from this side. As you guys can see. Pull this up on the board, on the schematic. Show you guys exactly what we're going to be changing out. U5630. P-bus SSD high side current sense. So let's go ahead and start switching out some of this corrosion. I'm going to turn on this fume extractor. and slap some flux on there. I'm just going to douse this in flux. I'm most likely going to see this board after, just because of the amount of liquid. I like to cover these shields as well with this little piece of rubber. That touch bar connector as well, this connector is responsible for display for the touch bar. It's usually pretty strong, but you don't want to hit it directly on with heat either. So let's go ahead and grab my tweezers and start switching some of this stuff out. I have a board, a very nice looking donor board here for this board. Yeah, it's very, very dusty. I think the customer stated they brought this to Apple. They told them like $1,400 to fix. Of course, the customer wants data. Apple said they're not sure if they can get data, but I think all they would do here is switch out the logic board. Just gonna heat this up. Yeah, this looks like really sticky. Pretty sure the customer said it was coffee. Well, I'll take that off. So you can see some of these pads look like they're kind of corroded away. So let's grab our Q-tips. We're going to clean this area out a little bit. Luckily, the pads look like they're still there. Most of them, for the most part. Just going to scrape away at these with a micro pencil. Oh yeah, I use the rubbers. You can use coins as well, but I do not want to melt those connectors, especially that touch bar connector is a real pain to put back on. Most of these pads look like they survived. I want to make sure that I'm not shorting something. So it looks like these two pads on the bottom left look like they kind of connected in between. I don't know if you guys maybe zoom in, give you guys a better view. Looks like those two pads, maybe the trace, not the trace, but some of the board came off in between. But if we take a look at our board view and schematic, these two pads are connected, so it should be fine. So I'm going to go ahead and apply new solder onto this because it looks terrible. Dan sounds pretty competent. Thank you, Paul Daniels. I'm going to go ahead and grab some solder. Wow, this is some really thick solder. And we're just going to go ahead and apply some new. We don't need this rubber piece for now. And apply some new solder onto all those pads, make them look nice and shiny. This maybe, there we go. Also the chips, we're going to be taking this from a donor board, so the chip will also have solder on it already. I don't like the way this looks. Can go ahead and touch up these joints. Not corroded, but don't like the way they look. He said solder, I take that back. And let's go ahead and grab our donor board. Very nice looking donor board, and we're gonna pull these components off. I'm not worried about melting the connector on this board since it's a donor board. I'm going to show you the other board as I'm placing these on. Fix this mic. There we go. Let's get this in view. Just so you guys can see better. Not enough flux. Yeah, so these boards have soldered on non-replaceable SSD storage, just like someone said in the chat. So unfortunately, when there's issues with the SSD and any of these lines are shorted, you can't just go ahead and switch out the SSD or do data recovery from that SSD. Since they're soldered on, it becomes much, much more complicated to fix than the old MacBooks. Go ahead and heat this up. I think I need to put a little bit more flux on there. So I'm just going to let that sit. You guys will see it just flow right into place when we put more flux on there. Let's just douse this in flux. There we go, and you see it float right into place nice like that. I'm going to go ahead and grab another cap from the stoner board. Let's go ahead and put this cap on as well. Let the solder dry, and then it should just pop right into place nicely. Give it a little tap. And let's move on to the next corroded part of this board. If you think you've used way too much flux, you haven't used enough flux. Very true. So, the next part I saw that was corroded on this board, this is actually the Ocarina chip. Some 1990 boards don't have this. I believe this customer had a higher spec board, possibly with more storage. That's why this Ocarina is here. There's a lot of boards that do not have this Ocarina. Rather, they have the one on the other side of the board. As you can see, it's pretty corroded. I'm going to go ahead and measure some of these signals, and I'll show you guys what I'm measuring on the schematic as well. Let's go ahead and pull this up. So yeah, this is the Ocarina chip right here, U9500. Let's go ahead and switch this to next page. As you can see, tons of SSD signals, 1 V8, 0 V9. Gonna go ahead and measure those. So, let's show the microscope. First thing I want to measure is 1 V8. Not shorted. I believe this one 0 V9 is only 50. That's pretty low actually. I believe it should be somewhere in like the 200 ohm range, so we might have an issue with this Ocarina chip. It does look like there's some liquid under it. 62 ohms, pretty low. 3v3, that's very shorted. So we're gonna go ahead and switch out this corrosion. First thing I want to do is, actually I might as well take all the components off. I was gonna switch out the caps first, but let's go ahead and slap some flux on there. Douse this in flux for all you Lewis watchers. And what I'm gonna do is I'm gonna grab this. There is as you guys can see, a connector right on top of it. It's the speaker connector. I'm just gonna cover that again with this nice little rubber mat. Yeah, unfortunately, before all you had to do to upgrade your storage was just get a higher SSD and plug it in. But now, unfortunately, we have customers sending us their devices with soldered-on SSDs, asking for upgrades, but we can't give them upgrades because just not economically viable. Especially because most of these NAND chips are underfilled. So I'll take off these corroded capacitors. There we go. I'm actually going to go ahead and take this Ocarina chip off as well. As you can see, there's just a ton of like sticky coffee under there. Maybe it's hard to see with the light. Let's take a look at this. Yeah, see, as you guys can see under, looks pretty bad. A bunch of corrosion got under there. I'm actually going to go and grab a new Ocarina chip. I think I have one reballed at my desk. So I'll be right back. So I'm back. I'm going to go ahead and clean out these pads, and I have a new freshly reballed Ocarina chip. I reballed some of the newer chips during my spare time. It's not too busy just to have. So what I'm going to do here... hello, Piernoff. Hello, Vince. Hello, everybody. Thank you for the warm welcome. Also, thank you for everyone that commented on my last board repair video. It's been about a month, I think, since the last one. Some really nice comments on there. Hopefully, do a little bit better this time. Let's go ahead and go. Oh, someone brought some thin solder. I'm going to go ahead and use this. So, what I'm going to do here is going to try to put some fresh solder on these pads. Fresh solder on these pads. Just because it's much easier to wick it when there's fresh solder on these pads. Go ahead, just doesn't really matter how it looks. Just gonna go ahead and wick this off. Put some more flux on there. So you guys can see. Let me just. There we go. And I have a new fresh wick. And And let's go ahead and wick this off carefully, not to knock anything off. Worst comes to worst, if you do knock it off, I'm lucky enough to have a donor board to replace this from. And this wick is giving me some trouble. There we go. Now let's go ahead and wick this off. Once again, I put on new solder just because it's much easier to wick these pads with new solder. The old one, sometimes it's harder to melt, takes more heat. And we want to use as little heat as possible. I am going to clean off this old flux while it's still warm and clean out any of the liquid coffee sticky substance that might be left on the board under it. First thing I want to do here too, is this chip generally dead after, or is it subjected to liquid damage? So, some of these chips are actually really water resistant, except for when the solder gets corroded under it. For the most part, we switch them out, but there are some chips, such as this Ocarina, for example, or CD3217s that aren't widely available. So, for example, for CD3217s, what we do is we'll usually reball the customers if the chip doesn't look too bad. You can see, let me see if I can show you guys on this old Ocarina chip. This one doesn't look too terrible. Just have to clean out some of this junk right here. For the sake of this video, I'm gonna go ahead and replace it. Doesn't look too bad. You'd see like black streaks running in the actual chip itself, or discoloration. On the CD3217s, it's easier to see because it's like a green. You'll see a dark green. That usually means the chip is bad. So we usually won't reuse it. That means it'll probably die in the future even if it works. But if you don't see any like discoloration between the layers of the conformal coating on the chip, then it's usually fine to just reuse it. And before someone invents a conformal coating inside the insulation, we usually don't place these chips in the UC. Once again, it's much easier to just replace it with a new one. Okay, so let's go ahead. I'm going to actually replace some of the caps that I took off first before putting this Ocarina off, because I don't want to move it when I reapply it. So I'm going to go ahead and put some flux on here and replace those chips that I took off. So let's go ahead and put some flux on the donor board too. Can you tell me what's up with the plushies? That is, I believe those are all Erica's. Are they for staff or customers? I think we have some actually in the front of the display. You can see it in Lewis's last tour video. Well, I'm gonna go ahead and replace these caps. Do this again. Actually gonna put some new solder on these because looks like I might have wicked some away. Lewis hasn't been doing streams. He's been really busy with other stuff, so you guys all see him traveling on all of his streams and all that. Actually, don't think I wicked this away. Let's put a little bit of solder on there. There we go. I like how that looks. And let's replace the rest of these components we took off. That dry up so it doesn't move. There we go. These, I don't know why these capacitors soldered together. There we go. And I'm gonna go ahead and put a new Ocarina chip on here. Actually, first thing I want to do while I have this Ocarina Chip off is I want to see if that short went away. So we want to see if that was actually the reason as to why it was shorted. So let's see. And that was not the reason. So let's go ahead and put this back on and see if something changes. So I want to go ahead and check the schematic. Bottom right. We're going to go ahead and replace this. Let me just clean this chip off a little bit so you can see where the first leg is supposed to be. And as you can see, here we have a freshly reballed Ocarina chip. Just gonna go ahead and put some, actually I already put flux, I'll put a little bit more on there. You wanna make sure we line this up properly. So let's move this up a little bit and then just casually float it into place. Go. And we want to slowly heat this up. I usually start a little bit further away, let the flux melt so the chip doesn't move out of place. The last thing you want to do is have it melt and then have to reball it again. Just gradually move closer. Oh, and you see it start to move and just nicely pop into place. Heat it directly a little bit, make sure all those solder balls under there are nice and melted. Okay. Don't want to overheat it too much though. And let's go ahead and check this once again. Okay, we might have another issue there, but I'm going to go ahead and move on and start replacing more of the corrosion that I can see on this board. Just want to make sure this all looks okay. It's fine, that'll clean off. So the next bit of corrosion I saw is right here on this MOSFET, right above TPS. And what exactly is this? Looks like some sort of MOSFET coming out of TPS 51980. It's where 3v3 becomes 5VG3S. Are those chokes, aka coils, those packages we saw? I think those were all capacitors, I believe. Let's double check. Someone asked in the chat. Oh no, they are coils, yep. There's a bunch of coils. Or fuses. Let's see. Where were we? Right here, I'm going to go ahead and replace this MOSFET because it's, you can see this blue tint of corrosion right on top. Right, it might be hard to see, but there's a bunch of blue corrosion. If I scrape away, yeah, look at that. That is nasty stuff. Let's go ahead and slap some flux on there. No connectors around here, so we don't really have to worry about melting anything. No, this customer fessed up to the spill. They're actually very worried about data, so they're actually very honest about everything that happened to this laptop. It was just a coffee spill on the keyboard. Took it to Apple first. They said $1,400, which is basically the price of this device. and currently. I think it was a little bit more at the time when they bought it. Apple also told them that they're not sure if they'll be able to save their data, but I can firmly tell this customer that they won't be able to save the data because they'll just replace the whole logic board. Again, I'm just grabbing this straight from a donor board. There we go. Brighter the camera. Let me see if I can do that real quick. There we go. Looks a little bit better. And this other MOSFET to the right of it as well. What is this? This QB701. Also corroded. 5 volts USB. So we're going to go ahead and change this out as well. 5 volt regulator. Right here. This one is one of those boards where you go into it thinking it's like I'd say like a 50% chance of repair, but kind of want to show you guys what we go through here, what we want to do here for a customer that's looking for data. We'll try everything to try and get them that data. Let's go ahead and take this off. You can see it like clumps of coffee right there. I'm going to go ahead and clean this off with a Q-tip as well. And you can see that there's coffee stains all over. Nice and clean pads. The pads weren't bridged with solder, just how they're connected on the schematic. Yeah, I actually can smell the coffee. Someone said in chat, can you tell the coffee flavor? It just smells like regular coffee. That's true, Mevin. Sometimes Apple doesn't want to be held responsible if they lose the data. That's why they just don't offer it. It's very true. But they usually wipe it most of the time. What temperature are you using for the heat gun and soldering iron? Soldering iron is set to, I think, 750. Hot air is set to 500 and 120 for the air. I'll heat this up. Pops right into place nicely. I'm going to press it down a little bit. I'll put some solder on this pad too. Go. Let me put some new solder on these as well. There we go. Why wouldn't you ultrasonic clean before servicing? Sometimes the ultrasonic will wash away most of the corrosion, almost always wash away all the corrosion. Makes it much easier to, let me see if I can, I don't know why this doesn't want to stay on much brighter. So what the UC will do, it'll clean away most of the corrosion, and then we won't know where to start. So makes it much easier to replace first what you see is corroded, so then that way, you know, if it cleans it out and only corrosion is under the chip, how would you know it's there? You know, and then you'd end up not knowing what is corroded and what you need to replace. So next point I want to move on to is the other side of the board with this Ocarina chip and this whole SSD area on the other wing of the board. Also, you kind of have to feel out for yourself what heat you use and whatnot. You also use it for, like someone said in the chat, your location/environment. So, for example, the location of the board you're working on, are there any components that can be damaged by too much heat? I'm I'm gonna replace these guys over here. Don't like the way they look. Yeah, so like someone said, basically gets rid of all the evidence for what was corroded. I'm gonna cover the shield. Don't like the way this pad looks. There we go. For some reason the camera doesn't want to stay brighter. Not sure why, honestly. So I'm going to go ahead and pull these components that I took off. I'm just changing them out because I didn't like the way they look. They look kind of corroded. Let's get some fresh flux on there. That dry up, put some new flux on there, and you'll see it just nicely pop into place. There we go. And we want to go ahead and change out this cap as well. On most of the boards, the first thing that dies on these 1990s is this guy you can see right here. I'll touch it with my tweezers. The SSD buck controller. Usually the first thing that dies. In this case, P-bus isn't shorted. Usually when P-bus isn't shorted, that doesn't die. I think that's TPS 62180. Let's take that off. I'm actually going to clean this out with a Q-tip. That look nice and shiny. I'm not sure why this apologizes Lewis's setup. I didn't really change anything. Let's go ahead and put this cap back on. Oh, so see that cap flew away. I'm going to show you guys what to do. Actually, a good example of what to do when a cap like that flies away. So let's go ahead and find that cap. So I'm not going to be searching Lewis's office where to find it. C9080. It's a 10UF cap. As you can see, there's a bunch of other caps on this board. You can also manually search it. Control F, find, for example, search 10UF and you'll find a similar cap. So what I'm going to do here is just right click this, so show me where it is on the schematic. On the board view, I should say, sorry. So I'm gonna go ahead and to the other side of the board. I'm just gonna go ahead and grab a cap from there. That one's also gone. So let's try this one, 9070. And I believe that one is also missing. So let's go ahead and check this one. I see everyone. This one is also missing. So now I'll give you a good example of what I do in this situation. Just Control F. And we're going to search for 10. UF. Just remember that it's a 25 volt cap, 0603 for the size. Oops, I think I typed the wrong thing. 10 UF. Example. And then we just want to search through the schematic and find a similar cap to that. 6.3 volts. If possible, you can also search through other. If you don't have a 1990 donor board, for example, you can check on 1707s. They're all the same. Just make sure it's the same size. Oh, there we go. We found one. C7077. This is right next to ISL 9240. And this one is here. So I'm going to go ahead and pull this from the donor board. You can also search the exact same measurement. It's the same on every board, so if you find something with the exact same specifications, you can just pull it from another board. I wasn't holding it too tight with my tweezers, so just went fine. I don't want to grab another cap from the desk because who knows where it could be from. Let's go ahead and switch to a microscope. Also going to put some more flux. That's probably why it went flying. There we go. And it floats nicely into place. Let's see if we can find anything else that's corroded on this board. I'm actually going to move this donor board to the side. And it actually looks like in this case the CPU Mosfets are also corroded. Also notice on most of these boards, customers really want data. The camera showing board is definitely underexposed. Yeah, I think it looks a little bit better now. So on these boards where customers really need data, all the worst areas are corroded. As you can see here, look at that. Right there on the CPU Mosfets. There, see there. This MOSFET looks okay, but we're definitely going to go ahead and change out these two. I'm going to go ahead and actually take off this LCD cable. I don't want to melt it while the cable is connected. That's going to be a nightmare to replace later. So I'm going to go ahead and take this LCD cable out before I start soldering in that area. I've had situations where I didn't take this out. I worked on the CPU Mosfets, which are right on the other side of this area. I try to take off the LCD cable later, and the connector's melted with the cable. So it's a new cable and a new connector. Okay, we're going to go ahead and replace the CPU Mosfets. I'm going to cover the heatsink with this rubber pad so it doesn't get too hot. And let's just put a ton of flux on this. The CPU Mosfets take a lot of heat to take off. Go around heating up this area. It's like a specific type of material. It's made by HAKKO, specifically for heat. It doesn't melt. If it does melt, it just forms right back into place. Kind of cool, actually. If you don't have that, you can just use coins. I usually use those for covering up bigger chips as well. This MOSFET's ready to come off. I'm going to take the other one off while this board is already hot in this area. Again, since we're getting close to the CPU and GPU, really don't want to be using too much heat for extended periods of time. There we go. Actually, don't even know if it's rubber. It's some type of material, elastic material. And we get that nice sizzle from how hot the board is. go ahead and clean this area out. And I don't like the way, I'm gonna scrape a little bit right here. Don't like the way this looks. Make sure that's nice and shiny. There might have been a little bit of residue left. Perfect. There we go. Check component above 1 that flew off. It moved during desoldering. It's fine. It moved back into place. Thank you, though, for the heads up. And let's go ahead and grab some CPU Mosfets from this donor board. So I actually wanted to make sure the CPU Mosfets, I'll show you how I do that, how to know if these CPU Mosfets are good from this donor board. This is my nice looking donor board I have here. Probably recycled from a customer's board we couldn't fix. And let's grab our multimeter. So, this board, we're going to measure P-bus on these two fuses I showed you earlier. As you can see, oh wow, it's actually not shorted. Might have taken the component that was shorted from here. Okay, never mind. So these CPU MOSFETs should be fine. Let's go ahead and, but in any case, how you would check if these CPU MOSFETs are fine, you would check, go ahead and grab it here, check P-bus, and then you would check P-bus to these coils, and as long as the measurement is higher than P-bus to ground, so for example here, all these different coils, your MOSFET should be fine. If they end up, so for example, if P-bus was 5 ohms to ground here, and on these coils it ends up being from P-bus to here, ends up being 3 ohms, those MOSFETs will most likely be bad. I just wanted to double check before I take these MOSFETs just to know that I'm not taking some bad ones and putting them on that board. Go. Switch back to the microscope. And we're going to put some new CPU MOSFETs on these. Of course, after I do, I usually tend not to see these newer boards. I do from time to time. In this situation, since there's so much liquid everywhere, I'm gonna end up using this after too. First, I want to make sure if it turns on though. That's why we're cleaning out all this corrosion. I'm just heating up the donor board to get this MOSFET off. Okay. Let's go ahead and heat up this flux. Put some more flux. I'm actually going to grab the second MOSFET while the board is still hot in that area, and then we'll make sure this one floats into place. But clear, I think we use Branson in the cleaner. The actual ultrasonic itself is Crest. We used to sell them, but I don't think we sell them anymore. Why don't I use gloves? I don't mind getting my hands dirty. I also feel weird wearing gloves. I only use it for when I'm doing some bigger components where hands might get really hot. Some more flux. Let's make sure this one's soldered on properly. There we go. And see that nice looking pads. I'm gonna move this one as well. And you'll see it start floating nicely into place. Give it a little bit of tap. Boom. Pops right into place. And all those pads look very nice. We're going to go ahead and touch up this one pad right here because it doesn't look too good. Want to make sure I don't mess up that cap. A little rough getting in there. There we go. And I'm going to let this board cool off. And then we'll do some more measurements and see. Got a rapid cooling technology. Of course, it's very hot because we're just directly heating it. Let's go ahead and pull this out, actually. I always want to double check and make sure things properly line up and fall into place. You guys can't see, but I'm just using this air to rapid cool my board. Then we'll do some measurements and see if we can find anything else wrong with this board. But yeah, if you just started tuning in now, what I've been doing so far, just cleaning off all this corrosion for this board. Customer wants data recovery. We'll see if we can get their data and give them a working device, of course. That would be the best. But if not, the customer will also be happy with just data. But I like to go the extra mile and give them a working laptop as well. Okay. Yep, board is nice and cool. So now that most of that corrosion is gone, I'm going to go ahead and grab a charge port and see if this turns on. And I don't see any charge ports here. Maybe Lewis has one in his stand. Of course not. So I'm going to go grab a charge port real quick so that we can test this or find one on this desk. I'll be right back. Okay, I am back. It's funny walking through the store and seeing people watching. Everyone actually becomes interested when someone does a stream. Hello, Olga. I see Olga commenting. So, let's move this donor board out of the way. And let's check what our device is doing now. Maybe do some measurements. Charger. 5 volts. 5 volts, 70 milliamps. Okay. 5 volts, 150. We do use distilled water. I believe so. I usually don't switch out the water. Probably should start doing it though. Kind of unfair to have everyone else doing it. So there might be an issue with either the CDs. And go ahead and look at some other areas of this board. This looks okay. This looks like just very dusty. Oh, looks like there's some liquid on this MOSFET. I'm gonna go ahead and change that out while I'm here. Put some flux on there. So let me show you what this is on the schematic. Let's pull this up. It's on this side of the board. Right here, Q3200. Yep, so just a MOSFET, CD3215. These usually have issues. I think I actually did it in my last video. These MOSFETs, lots of issues. Almost all our donor boards are missing these MOSFETs because of how many times we find issues with them. It actually is almost time for the thermal camera. Switch back to the microscope. You go ahead and change this out. Let me grab this, cover this shield. I believe Thunderbolt chip is under there. I don't want to heat that guy up. In this case, it's not underfilled, so should be fine. Yep, there's a ton of sticky stuff on this MOSFET. I'm going to clean that out. Q-tip. Let's go ahead and grab it from our donor board. And that popped into place nicely because of the flux. Let's go ahead and cool off this board once again. I'm going to plug it in and see if anything changed from that corrosion. 1 Lewis of flux, please. I think I'm one of the people here that uses just as much flux as Lewis. Actually, no one uses as much flux as Lewis, but very close. Either way, even using a lot of flux, those tubes usually last a few months. Okay, so they cooled off enough for us to plug in and check. Well, let's see what's going on now. It didn't end up failing, it was corroded, so we're gonna go ahead and change it out. And we're still having issues. Might be time for less flux. Might be time for thermal cam. So we can see what's actually going on here. Maybe I can find some more corroded components. Looks fine. Well, I'm gonna go see if I can hook this up to the thermal cam and see what's getting hot. So I'll be right back. Okay, I am back. Apologies for not showing the chair on stream. I'm not used to doing that like Lewis. So I went ahead and hooked this up to my thermal cam at my desk. I don't know how to set it up on Lewis's setup. I apologize. This port was taking 5 volts, 150 milliamps. This CD looks like there's a short on the CD. The very corner of it's getting extremely hot. So I'm going to go ahead and change out this CD. Could be damage from the dust or liquid. As we saw, there was liquid on the other side of the board. So let's go ahead and switch out this CD. This is a 1990, not a 1707. Very similar though. Very, very similar, just different years. Slightly different chips as well. Like for example, 1990 has ISL 9240, while 1707 has ISL 9239. Just go ahead and take off this CD. Luckily, it's not underfilled on these boards. So let me adjust this nicely. You can see there's dust and like, looks like almost like coffee stained dust all over this. Nicely heat all around this. This corner of the chip actually looks kind of burnt. Okay. Pads look fine. Underside of the chip also looks fine. Yeah, luckily that thermal cam is put to very good use in our store. So once again, I'm going to go ahead and put some fresh solder on these pads. Make it easier to wick them off. So luckily this 1990 still has CD3215, not CD3217. Let's clean the solder off this tip. And let us cut this wick. Go. And we're going to wick these pads nicely. Put a little bit more flux on there. Okay, those pads look pretty clean. Two of them look to have linked together, but most likely let's take a look at the schematic. Show you guys which part of the board I'm actually looking at. Where the hell did this board go? Let's reopen the schematic because for some reason it disappeared. Okay. What the hell happened to this board view? Okay, I guess board just wanted to disappear on me. Let's reopen the schematic software. Yeah, for some reason it disappeared and it won't. They aren't soldered together, but some of the board's conformal coating came off. Let's see if I can fix this board view software to show you guys why that's not an issue. There we go. Got this board back. Let me just set this up so it looks nice for you guys. Okay, just go ahead and pop that back on the screen. So, this is the CD we're switching out now. And these are the two pads that look soldered together, but they're not. They're the same thing, so there's no harm in replacing it with those pads looking like that. Yep. So let's switch back. Let's go ahead and replace it. So as you guys can see in the top left corner right here, this shouldn't be an issue. Same signal. So if those two balls connect, there won't be any issues with the board. Gonna go ahead and grab a new CD3215. Just make sure I have the right orientation. Luckily, we don't have to reball these because we sell them on our store, store.rossmangroup.com. Go ahead and dump some flux. Just gonna lightly heat this up so it makes it easier for the chip to fall into place, doesn't move around. And I'm going to try to lightly put this into place. And I'm going to try heating from further away a little bit. And this resistor moved a little bit. I'm gonna let it cool off, and then I'm gonna move it into place. I just don't want to touch the CD and have it move. Lightly turn this so I don't tap it either. Actually gonna turn this board around, make it easier, because I'm using my left hand to solder. Because I don't want to move that CD. Makes it very easy for them to, for it to move. There we go. And I'm going to go ahead and cool this board off, and then we're going to see what's going on. Show this board view while the board is cooling off. Yep, so we just replaced this CD3215. It was getting hot under the thermal cam. All the ports are doing something different, so I feel for me it indicates that something's wrong with the CDs. And I'll show you guys. Let's see what happens. So I'm new to all this. What are you using to heat that? I'm using a hot air gun. Lewis's current office setup, I think it's the Quick. He has a Quick setup. We sell Latins on our website. Everyone here uses a different one. Lewis still uses the Quick because, I mean, it's a working machine. Why would he throw it out? But it's very, very similar to the Atin that we sell now. The heat I currently have it set to is 500 and 120 air. And let's go ahead and plug this board in and see what it's doing now. Okay, it's doing something different now than it was before. Five volts, 200 milliamps, 100 milliamps. Still stuck on 5 volts though. So I'm gonna go ahead and throw this under Please Bro one more time. And we'll see. And who knew, with my luck, the CD3215 on the other side of the board is also dead. So, let's go ahead and show you guys. The CD3215 was getting extremely hot as well. It was kind of pulsing under the camera. So we're going to go ahead and switch this one out. What I'm going to do is cover up this connector right here with this piece of rubber. And we're going to go ahead and change this one out. Can you read the comments? If so, would you move out of New York City? I would highly, highly consider it. Depending on where he goes, Lewis, if you're listening to this, please choose Florida. The other soldering station, does it have a blue backlit display and silver in color? Yep, that's the one Lewis uses. The ones we used to sell. I'm not sure if there's a difference. We always use the C00s without the Z. They've worked for every board I've tried using them on, but there may be a slight difference. Step Brother Dan, I like that nickname. So once again, going to go ahead and put some fresh solder on this. Looks like one of our capacitors might have moved as well on the bottom right, but we'll go ahead and push that back into place. Yeah, I'm going to go ahead and quickly move that back into place before we go and do this CD. There we go. Cut this wick, get some fresh wick. A little bit more flux on there too. I tried on a 1989 and didn't work. It was known good chip, and that's why I was wondering if there was a difference on them. I would check and see which one it was that you took off and try to replace it with the same one, but I can't recall having issues with that. But there's always that possibility, because I'm not sure. Let's try to nicely take this off without pulling anything off with it. So I want to make sure these pads are as clean as possible so that chip sits nicely. If you leave a little bit of solder on there, you might move the CD while you're putting it on. And looks pretty good. Maybe a little bit right there. There we go. Let's clean off this burnt flux. Put some new flux on there. We're gonna grab a new CD as well. Don't like the way that looks. I want to get a little bit more of that solder off. I think this might cause an issue right here. There we go. Beautiful. Once again, those two pads are going together, but if we take a look at the board view, yeah, that's fine. Those two are the same signal as well. Let's go ahead and put a new one on. Reopen this board view, is glitching again. Just want to make sure I have the right orientation for this chip. And it should be on the bottom. First leg is on the bottom right. Where are you from? I'm wondering because you said I pronounced the L. I am from US. Cover this connector once again with this pad I have. And I want to nicely put this into place before I start heating so that it pops in nicely. I want to make sure we don't see any pads on the side. Just tap it in, you'll feel it move nicely into place. You can see some little residue from liquid damage here as well. And we're just going to lightly heat this until we see this CD fall into place. Well, and you see it move. There we go. And we're going to cool off this board. Just want to let it sit in place. I've had times where I moved the board too quickly and that CD3215 will just move out of place. And it's a nightmare, so. Again, we just switched out this CD right here. It's getting hot under, please, bro. Thermal cam. Sure, it's on right. Pin 1 is on bottom right. Yeah. Oh, actually, someone is right. Wow, I didn't even catch that. I'm gonna go grab some new ones from my desk. Okay, I am back. Grabbed a new CD. Someone pointed out mistake I made, and they're actually alright. I actually did put this one on wrong. No problem though, we're gonna go ahead and take it off and put it on properly. How long have I been repairing? I've been doing it for about a year, so I do still make some small mistakes. Like this one was actually a newbie mistake, but we would have caught this pretty quickly. Originally I was doing shipping for Lewis, and then I learned myself from the people that work here and from Lewis's videos. Now I'm doing board repair. I think it's been about coming up on a full year since I started doing board repair full time. Since that chip had fresh solder on it, I'm not going to put any new one on. I'm just going to wick this off quickly. Need more flux. Cut this one more time. Go and just get these last little pads down here and right there. And I want to make sure all these pads are nice and clean. Yeah, that's the best way to practice, just buying used, really beat up machines that you won't mind breaking. That's pretty much how I started when I was doing it here. They'd give me like donor boards that were like fixable, for example, and they'd specifically mess something up on purpose that they knew was wrong. And like, oh, go find what's wrong. And over time, you just learn. And we grab a new CD. There we go. Make sure we're putting it on properly this time, bottom right. Even though I said it last time, I think I was too focused on reading the chat. How much flux have I used? A lot. Well, it looks like a lot, but in reality, actually not that much. Usually I use a little bit less, but since I'm going to be using this board later, don't mind. So just have this chip pop into place before we start heating up the board. Looks about right. Once again, I'm going to lightly heat this up from further away. Just want to make sure we're covering that connector. But worst comes to worst, we can always replace it. And we see that chip nicely move into place. Now I'll make it swim a little bit in the flux, make sure all that solder is melted. There we go. And let's go ahead and cool this off. Have our fume extractor. Once again, for those of you just tuning in, doing a Liquid Damage 1990 820-01041 board. Customers is interested in data. Went ahead and checked under thermal cam. The CDs on this side of the board were getting very hot. I'm just gonna let this board cool off before we plug it in. And I just realized that I took my charge port back to my desk, so we're gonna go ahead and grab that and test this board. So I'm gonna let this cool off. Let's go ahead and grab our charge port. So I am back. Let's see what this board is doing now. So we switched out those two CDs that were getting hot. Someone said, hello, Dan. I hope you're having a fantastic day. I am. Hopefully, we can get this board to work for you guys. Oops. Something stuck in this port. Go. Make sure I get this on the screen for you guys. 5 volts, 400 milliamps. Looks like it's power cycling. Now this port's doing the same thing as the other one. Before we had 70 milliamps on this port. See if we can see what's going on this side. Every port's doing the same thing. So I'm gonna go ahead and hook this up to the thermal cam one more time. Maybe we can see something else getting hot. Well, I'll be right back. So I'm back once again, and guess what we found out? The other two CDs are also dead. Just my luck. Both CDs on this side are also getting extremely hot. Very, very hot, actually. So it seems like something might have zapped all of our CDs. It wasn't going to 20 volts. It was stuck on, it was on 5 volts and going to like 500 milliamps. It should be enough to turn it on except for the 20 volts, if it was 20 volts, but it was not. It's only 5 volts. What a pain in the ass board, I know. Something pulled straight out of my queue. So unfortunately I couldn't show you guys the thermal cam. I don't know if Lewis has any setup here for it. I don't think he does, actually. Okay, take that one off. And get both. Let's make sure we didn't knock anything off. I don't think we did. Just gonna go ahead and replace both of these at the same time. Let's put some flux and fresh solder to get this pads nice and clean. Oh, we actually pulled the capacitor off there. We'll go ahead and replace that from our donor board. I imagine this job would be very difficult if you're someone with very shaky hands. Usually my hands aren't shaky, but I think everyone knows how it is when you're doing your stream. I only put fresh solder on there just to get the other one off. Where did you learn to repair electronics? I learned here. Yeah, nice fresh tip. All of my knowledge of repairing electronics, MacBooks, has come from this job. And my own time learning from Lewis's channel and whatnot. I'd definitely recommend watching some of his older videos. They're really, really informative if you're just starting out. Okay, I'm gonna cut this wick. Yeah, Lewis actually offers a lot of really good, not only programs, but for example, the wiki. Tons of information for boards. Also have our forum. Some great technicians answering questions there. Okay, let's go ahead and clean off this old flux. Oh, also his PowerPoint. That's another thing where I started from too. Does a really good job of explaining electronics. Dumbed it down for people even like me to learn. See, some of those pads are also look like they're soldered together, but those are all the same thing. Just gonna go ahead and open this on the board view. Switch to the schematic and board view. I think it was this one. See, all four of these are linked together, so it should be no issue. And like I said at the beginning, this is one of those boards where it just looks like rabbit hole after rabbit hole from how much liquid. And let's switch to microscope. And let's replace these CDs. Actually, I'm going to go ahead and put on the capacitor that fell off while I was wicking. Move this microscope. Yeah, unfortunately most people let their devices sit, don't unplug the battery. The best thing you can actually do is unplug the battery. But they'll let these devices sit, and once they sit and they corrode, it just becomes much, much harder. Not all boards, only the boards that are really bad like this one, completely covered in liquid. Sometimes, you know, just not worth putting it through the UC, because the UC could actually kill a board as well. Go, put those components back on that we knocked off. Yeah, that's very true actually. Most don't have a pentalobe. Apple does make it much harder for the average person to open these MacBooks. Also need to be careful if you don't know exactly what you're doing. You know, might short something or damage something while you're opening it. I think Paul did a stream yesterday where he showed what happens when people try to open MacBooks on their own with screwdrivers on the side, and it knocks components off. So let's go ahead and put this CD on. Go, you see it float into place nicely. Go. Some more flux on this side. Try to get this on while it's still hot. I'm guessing which components are interested and which aren't. So show you now, most of these chips have little markings on them. The bigger chips, you can see on the bottom right corner, you can see that circle. That indicates where the first leg is. when we switch to the board view and schematic, here's the first leg, so you'd know to match it up with the same orientation as that circle. And I'll show you where to put it down properly. Gonna go ahead and cool off this board, and we'll see what changes. So far up to this point, we switched a ton of liquid damage. All 4 CDs were getting hot under the thermal cam. Just gonna let this cool off before we plug it in. Hopefully it'll turn on for us. Yeah, underfilled CDs. I think only the 1706 and 1989 have underfilled CDs. I actually really like doing them. They're a pain to do, but they're kind of fun. Unless you rip a pad, and then you're in for a treat. Nope, board's nice and cool. And let's see what's going on now. And we have 20 volts, 300 milliamps, 200, 1.6 amps. So this should be turning on. I'm going to grab his test screen, and let's see if we get Apple logo or not. Move this over. I have a test screen here. I believe it works. Actually need to go ahead and put LCD cable back on. Just going to go ahead and screw these in properly. Yeah, I like underfilled. I don't know what it is about it. At first, I think my first one took me like an hour to do at least. There's something about it that's fun. I think I've had a few boards just like this one where all 4 CDs are bad, but they're all underfilled. Okay, we can go ahead. Let's go ahead and check for Apple logo. I'm actually gonna put this in right there. Let's move this microscope a little bit. And let's see if we get Apple logo or not. Oh, 5 volts, 300 milliamps, 20 volts, 200, 300, should pop up over an amp. There we go. And we have Apple logo. So I'm not going to let this boot just in case. I don't want to show the customer's information. Honestly, I'm kind of surprised that this one did work. Yeah, don't worry, I'm not going to dox the customer. A lot of liquid, really. We have Ocarina. We had to replace 4 CD3215s. Tons of areas around the SSD and other things. Hopefully this boots properly. Nothing else is wrong with their computer, but we can definitely get access to their data since this is turning on. Yeah, so for now, this device is fixed. Thank you so much for watching, guys. Sorry for the long video, but it is a long repair. And that's kind of what goes into heavily liquid damaged devices like this one, where a customer really needs data. We'll do anything to get it back for them. So thanks for watching, guys, and until next time.